lacking main battle tanks. Offensive capabilities. A sectioned 105mm rifled Royal Ordnance L7 tank gun. The main weapon of modern tanks is typically a single, large caliber cannon mounted in a fully traversing, rotating, gun turret. The typical modern tank gun is a smoothbore weapon capable of firing a variety of ammunition, including armor-piercing kinetic energy penetrators, KEP, also known as armor-piercing discarding sabot, APDS, and / or armor-piercing finstabilized discarding sabot, APFSTS, and high-explosive anti-tank, heat, shells, and / or high-explosive squash head, HESH, and / or anti-tank guided missiles, ATGM, to destroy armored targets, as well as high-explosive, HE, shells for shooting at soft targets. Unarmored vehicles or troops, or fortifications. Canister shot may be used in close or urban combat situations where the risk of hitting friendly forces with shrapnel from HE rounds is unacceptably high. 60. A gyroscope is used to stabilize the main gun, allowing it to be effectively aimed and fired at the short halt or on the move. Modern tank guns are also commonly fitted with insulating thermal sleeves to reduce gun barrel warping caused by uneven thermal expansion, bore evacuators to minimize gun firing fumes entering the crew compartment, and sometimes muzzle brakes to minimize the effect of recoil on accuracy and rate of fire. German Leopard 2A6 from a Panzer battalion fires its main gun during the shoot-off of Strong Europe Tank Challenge. A Merkava MKIIID Baz firing. Traditionally, target detection relied on visual identification. Guise was accomplished from within the tank through telescopic periscopes. Often, however, tank commanders would open up the hatch to view the outside surroundings, which improved situational awareness but incurred the penalty of vulnerability to sniper fire. Though several developments in target detection have taken place, these methods are still common practice. In the 2010s, more electronic target detection methods are available. In some cases, spotting rifles were used to confirm proper trajectory and range to a target. These spotting rifles were mounted coaxially to the main gun, and fired tracer ammunition ballistically matched to the gun itself. The gunner would track the movement of the tracer round in flight, and upon impact with a hard surface, it would give off a flash and a puff of smoke, after which the main gun was immediately fired. However, this slow method has been mostly superseded by laser range-finding equipment. Modern tanks also use sophisticated light intensification and thermal imaging equipment to improve fighting capability at night, in weather and in smoke. The accuracy of modern tank guns is pushed to the mechanical limit by computerized fire control systems. A fire control system uses a laser rangefinder to determine the range to the target, a thermocouple, an anemometer and wind vane to correct for weather effects, and a muzzle referencing system to correct for gun barrel temperature, warping and wear. Two sightings of a target with the rangefinder enable calculation of the target movement vector. This information is combined with the known movement of the tank and the principles of ballistics to calculate the elevation and aim point that maximizes the probability of hitting the target. Usually, tanks carry smaller caliber armament for short-range defense where fire from the main weapon would be ineffective or wasteful, for example when engaging infantry, light vehicles or close air support aircraft. A typical complement of secondary weapons is a general-purpose machine gun mounted coaxially with the main gun, and a heavier anti-aircraft capable machine gun on the turret roof. Some tanks also have a hull-mounted machine gun. These weapons are often modified variants of those used by infantry, and souse the same kinds of ammunition. Protection and countermeasures. The measure of a tank's protection is the combination of its ability to avoid detection, due to having a low profile and through the use of camouflage, to avoid being hit by enemy fire, its resistance to the effects of enemy fire, and its capacity to sustain damage whilst still completing its objective, or at least protecting its crew. This is done by a variety of countermeasures, such as armor plating and reactive defenses, as well as more complex ones such as heat emissions reduction. The Russian T-90 is fitted with a threaded protection systems 1. Composite armor in the turret 2. Third generation Contact 5 Era 3. Stra 1 countermeasures suite. In common with most unit types, tanks are subject to additional hazards in dense wooded and urban combat environments which largely negate the advantages of the tank's long-range firepower and mobility, limit the crew's detection capabilities and can restrict turret traverse. Despite these disadvantages, tanks retain high survivability against previous generation rocket-propelled grenadiers aimed at the most armored sections. However, as effective and advanced as armor plating has become, tank survivability against newer generation tandem warhead anti-tank missiles is a concern for military planners. 74. Tandem warhead RPGs use 2 warheads to full active protection systems. A first dummy warhead is fired first, to trigger the active defenses with the real warhead following it. For example, the RPG-29 from 1980s is able to penetrate the frontal hull armor of the Challenger 2-75, and also managed to damage AM-1 Abrams. 76, as well. Even tanks with advanced armor plating can have their tracks or gear cogs damaged by RPGs, which may render them immobile or hinder the mobility. Despite all of the advances in armor plating, a tank with its hatches open remains vulnerable to Molotov cocktail, gasoline bombs, and grenades. Even a buttoned-up tank may have components which are vulnerable to Molotov cocktails, such as optics, extra gas cans and extra ammunition stored on the outside of the tank. Avoiding detection. PLA's Type 99, a tank with disruptive camouflage painting. A tank avoids detection using the doctrine of countermeasures known as CCD. Camouflage looks the same as the surroundings. Concealment cannot be seen, and deception looks like something else. Camouflage. A British Challenger 2 theatre entry standard fitted with a mobile camouflage system. Camouflage can include a disruptive painted shapes on the tank to break up the distinctive appearance and silhouette of a tank. Netting or actual branches from the surrounding landscape aerials are used. Prior to development of infrared technology, tanks were often given a coating of camouflage paint that, depending on environmental region or season, would allow it to blend in with the rest of its environment. A tank operating in wooded areas would typically get a green and brown paint job. A tank in a winter environment would get white paint, often mixed with some darker colors. Tanks in the desert often get khaki paint jobs. The Russian Naked K camouflage kit was designed to reduce the optical, thermal, infrared, and radar signatures of a tank, so that acquisition of the tank would be difficult. According to Niai Stali, the designers of Naked K would reduce the probabilities of detection via visual and near-IR bands by 30%, thermal band by 2-3-fold, radar band by 6-fold, and radar thermal band to near background levels. 77. Concealment. Concealment can include hiding the tank among trees or digging in the tank by having a combat bulldozer dig out part of a hill, so that much of the tank will be hidden. A tank commander can conceal the tank by using hull-down approaches to going over upward-sloping hills, so that she or he can look out the commander's cupola without the distinctive-looking main cannon cresting over the hill. Adopting a turret-down or hull-down position reduces the visible silhouette of a tank as well as providing the added protection of a position in defilade. Working against efforts to avoid detection is the fact that a tank is a large metallic object with a distinctive angular silhouette that emits copious heat and engine noise. A tank that is operating in cold weather or which needs to use its radio or other communications or target detecting electronics will need to start its engine regularly to maintain its battery power, which will create engine noise. Consequently, it is difficult to effectively camouflage a tank in the absence of some form of cover or concealment, for example, woods. It can hide its hull behind. The tank becomes easier to detect when moving, typically, whenever it is in use, due to the large, distinctive auditory, vibration and thermal signature of its engine and power plant. Tank tracks and dust clouds also betray past or present tank movement. Switched off tanks are vulnerable to infrared detection due to differences between the thermal conductivity and therefore heat dissipation of the metallic tank and its surroundings. At close range the tank can be detected even when powered down and fully concealed due to the column of warmer air above the tank and the smell of diesel or gasoline. Thermal blankets slow the rate of heat emission and some thermal camouflage nets use a mix of materials with differing thermal properties to operate in the infrared as well as visible spectrum. Grenade launchers can rapidly deploy a smoke screen that is opaque to infrared light, to hide it from the thermal viewer of another tank. In addition to using its own grenade launchers, a tank commander could call in an artillery unit to provide smoke cover. Some tanks can produce a smoke screen. Sometimes camouflage and concealment are used at the same time. For example, a camouflage painted and branch-covered tank, camouflage, may be hidden behind a hill or in a dug-in emplacement, concealment. Deception. Troops carry a lightweight wood-framed dummy tank in top position. Some armored recovery vehicles, often tracked, tank chassis-based tow trucks for tanks, have dummy turrets and cannons. This makes it less likely that enemy tanks will fire on these vehicles. Some armies shave fake dummy tanks made of wood which troops can carry in top position and hide behind obstacles. These dummy tanks may cause an enemy to think that there are more tanks than are actually possessed. Armor. To effectively protect the tank and its crew, tank armor must counter a wide variety of anti-tank threats. Protection against kinetic energy penetrators and high-explosive anti-tank, heat, shells fired by other tanks is of primary importance, but tank armor also aims to protect against infantry mortars, grenades, rocket-propelled grenades, anti-tank guided missiles, anti-tank mines, anti-tank rifles, bombs, direct artillery hits, and, less often, nuclear, biological and chemical threats, any of which could disable or destroy a tank or its crew. The British Challenger 2 is protected by second-generation Kevlar steel armor plate was the earliest type of armor. The Germans pioneered the use of face-hardened steel during World War II and the Soviets also achieved improved protection with sloped armor technology. World War II developments led to the obsolescence of homogeneous steel armor with the development of shaped charge warheads, exemplified by the Panzerfaust and bazooka infantry carried weapons which were effective, despite some early success with spaced armor. Magnetic mines led to the development of anti-magnetic paste and paint. From World War II to the modern era, troops added improvised armor to tanks while in combat settings such as sandbags or pieces of old armor plating. British tank researchers took the next step with the development of Kevlar armor, or more generally composite armor, incorporating ceramics and plastics in a resin matrix between steel plates, which provided good protection against heat weapons. High-explosive squash-head warheads led to anti-polymer linings, and kinetic energy penetrators led to the inclusion of exotic materials like a matrix of depleted uranium into a composite armor configuration. Blazer explosive reactive armor, ERA. Blocks on an Israeli M60 reactive armor consists of small explosive-filled metal boxes that detonate when hit by the metallic jet projected by an exploding HEAT warhead, causing their metal plates to disrupt it. Tandem warheads defeat reactive armor by causing the armor to detonate prematurely. Modern reactive armor protects itself from tandem warheads by having a thicker front metal plate to prevent the precursor charge from detonating the explosive in the reactive armor. Reactive armors can also reduce the penetrative abilities of kinetic energy penetrators by deforming the penetrator with the metal plates on the reactive armor, thereby reducing its effectiveness against the main armor of the tank. Active protection system. IDF Merkava Mk4 tank with trophy APS, during training. The latest generation of protective measures for tanks are active protection systems. The term active is used to contrast these approaches with the armor used as the primary protective approach in earlier tanks. Soft kill measures, such as the Russian Shtra countermeasure system, provide protection by interfering with enemy targeting and fire control systems, thus making it harder for the enemy threats to lock onto the targeted tank. Hard kill systems intercept incoming threats with a projectile of its own, destroying the threat. For example, the Israeli Trophy destroys an incoming rocket or missile with shotgun-like projectiles. The Soviet Drozd, the Russian Arena, the Israeli Trophy and Iron Fist, Polish Irawa, and the American Quick Kill systems show the potential to dramatically improve protection for tanks against missiles, RPGs and potentially kinetic energy penetrator attacks, but concerns regarding a danger zone for nearby troops remain. Mobility. Two German Army Leopard 2s demonstrate their deep wadding capabilities. Mobility of a tank is described by its battlefield or tactical mobility, its operational mobility, and its strategic mobility. Tactical mobility can be broken down firstly into agility, describing the tank's acceleration, braking, speed and rate of turn on various terrain, and secondly obstacle clearance, the tank's ability to travel over vertical obstacles like low walls or trenches or through water. Operational mobility is a function of maneuver range, but also of size and weight, and the resulting limitations and options for maneuver. Strategic mobility is the ability of the tanks of an armed force to arrive in a timely, cost-effective, and synchronized fashion. Tactical mobility. M1 Abrams offloading from landing craft air-cushioned vehicle. Tank agility is a function of the weight of the tank due to its inertia, high maneuvering and its ground pressure, the power output of the installed power plant and the tank transmission and track design. In addition, rough terrain effectively limits the tank's speed through the stress it puts on the suspension and the crew. A breakthrough in this area was achieved during World War II when improved suspension systems were developed that allowed better cross-country performance and limited firing on the move. Systems like the earlier Christie or later torsion bar suspension developed by Ferdinand Porsche dramatically improved the tank's cross-country performance and overall mobility. 78. Tanks are highly mobile and able to travel over most types of terrain due to their continuous tracks and advanced suspension. The tracks disperse the weight of the vehicle over a large area, resulting in less ground pressure. A tank can travel at approximately 40 km per hour, 25 miles per hour, across flat terrain and up to 70 km per hour, 43 miles per hour, on roads. But due to the mechanical strain this places on the vehicle and the logistical strain on fuel delivery and tank maintenance, these must be considered burst speeds that invite mechanical failure of engine and transmission systems. Consequently, wheeled tank transporters and rail infrastructure is used wherever possible for long-distance tank transport. The limitations of long-range tank mobility can be viewed in sharp contrast to that of wheeled armored fighting vehicles. The majority of blitzkrieg operations were conducted at the pedestrian pace of 5 km per hour, 3.1 miles per hour, and that was only achieved on the roads of France. 79. The tank's power plant supplies kinetic energy to move the tank, and electric power via generator tow components such as the turret rotation motors and the tank's electronic systems. The tank power plant HACE evolved from predominantly petrol and adapted large displacement aeronautical or automotive engines during World Wars I and II, through diesel engines to advanced multi-fuel diesel engines, and powerful, per unit weight, but fuel-hungry gas turbines in the T-80 and M1 Abrams.